In this, we study basics of complex numbers that you need for algebra or pre-calculus classes. So before we talk about complex numbers, let's see what happens when you square a real number. So consider. So we talk about three cases. Let's say you square 3. So 3 squared. When you square 3, this means that 3 times 3. So 3 times 3 means 9. And then let's look at what happens if you have negative 3 squared. Negative 3 squared. So negative 3 squared means negative 3 times negative 3. So negative means positive. So you get positive 9 again. So when you square 3, you get 9. When you square negative 3, you still get 9. How about 0? So if you square 0, so 0 is squared. This also means that 0 times 0. So you get 0. So you can see that when you square a positive number, you get positive. When you square a negative number, you still get positive. And when you square 0, you get 0. So that means either you get a positive number or a 0. That means for any real number, so we can write this statement. For any real number, for any real number, for any real number x, we see that x squared, when you square, either it is positive or 0. So that's what happened. So this is a statement. So that's what always happens when you have a real number. So that means if you need a square to be negative, so you see that then it cannot be a real number, because when you square a real number, you get either positive or 0. So that means we need a new class of numbers, and we call this new class a complex numbers. That's like a new type of numbers. We call this complex numbers. So let's look at the basics of complex numbers. Complex numbers has a 1 or a unit, and we denoted this by a small lowercase I. So for complex number I, for complex unit, so for complex unit I, we define this as, when you square this I, so I squared, we define this as -1. So this is a definition. This is a definition. So this is what we call complex unit I. It's like 1. And then we can represent this one. This is a representation. We can also write this informally I as, if you take the square root, we can write this one as -1 square root. So this is a notation. This notation is I is -1 square root. That's a special one. So this is not real. These are what we call complex numbers. And we call this is the imaginary unit. So we call this is the imaginary unit. It's like 1. Imaginary unit. Imaginary unit. So that's the reason why we use the I, because for imaginary. It's not real. It's imaginary numbers. Now the question is how to write a complex number. So we write a complex number as two quantities. So we're going to sum them together. So we can write, for example, let's say we can write 2 plus 3 times of the imaginary part. So this is how we write a complex number. So when you have a complex number, there are two parts. The first part, what we normally call the real part. The real part. Because that's a real number. The second part we call the imaginary part. Imaginary part. Imaginary part. So there are two parts, and then when you have both parts, we call this is a complex number. So we call a complex number. So complex number has two parts. Complex number. Even like some part can be 0. So that means a real number is a complex number in general. So, and also there's another representation that can be useful later, but we don't need that for this this discussion, but I'm going to write it. We normally put the real part on the x-axis. That's a real part. So put the real part on the x-axis is a real part, and then on the y-axis we put the imaginary part. That's how we normally write this is a representation. So it's an imaginary part. So what we do, we're going to put 2 as the x-coordinate, and then we're going to put 3 as the y coordinate, and then this coordinate you can represent the complex number. So you can say, so this is a representation. So this ordered pair 2 3 represent the complex number. That's a representation. And also there's another way, we also sometimes draw an arrow for the vector. This is what you call a vector. Vector means something which has a direction and a magnitude. So this is another way. So we have several ways to write a complex number. One is like you can write as 2 plus 3i. The other one is you can represent this as an ordered pair 2 3. Also you can write a vector to represent the complex number. Sometimes we use the z for complex numbers. So this is simply 2 plus 3i. These are representations, but we don't need this one for this discussion. Okay, now let's see how we can do algebra with complex numbers. Algebra of complex numbers. So let's look at the first one. First one is how to add or subtract complex numbers. So addition and subtraction. Addition and subtraction of complex numbers. So what we do, the easiest way, just consider I just like x, like a variable. So that is the easiest way to work with complex numbers. So for example, we can do 2 examples. So how about 2 plus 3i plus, let's say, negative 5 plus 8i. So if you have those two complex numbers, what we can do is we work with real numbers and imaginary part separately. So that means we're gonna go with 2 and 5. So you can add them together first. So that means it is 2. In this case, is minus 5. That's the first part, real part, and plus, and we do the same thing with the imaginary part. So we just consider I is like x, like a variable. So you can write this one as 3. So what we have is 3 plus 8, those are 2 numbers, and times I. Now we're going to simplify this one. So from the first one, you will get negative 3 plus 3 plus 8 means 11i. So that is the answer from the addition. So as you can see, it's very simple. And let's look at a subtraction problem. Let's say we have 2 plus 3i. Now we're going to subtract them. So let's say subtract negative 5 plus 8i. So in this case, what we do, we just subtract them as before. Last time we add, now we subtract them. We're going to subtract these two, and then so what we're going to get is, so you can see it is 2 minus 5. So what we do, we subtract, and then plus, and then we can also subtract the imaginary part as we did for the addition. So that means you're going to get 3, and then you subtract 8, and then I. So that means if you simplify, you're going to get a negative, negative, positive. So you get 2 plus 5. So you're going to get 2 plus 5, and then here you're going to get negative 5 I, and then we can write this one as 7 minus 5i. So that's how we're going to write it. We don't write plus minus there. That's one way to do it. And there's another way to do this problem. So what we can do is, let's say we start with the same problem, 2 plus 3i minus negative 5 plus 8i. What we can do is we can distribute. We can simply distribute the negative sign. So we can write this one as 2 plus 3i. If we distribute the negative sign, you're going to get positive 5, negative 8. Now, as before, as we did the sum problem, so you can add the real part, so you're going to get 7. And then also you can simplify the imaginary part, you're going to get negative 5i. You can see you get the same answer. But in the second one, we simply distribute the negative sign. So it looks like that's easier compared to the other one. So, but you can do this in 2 different ways. So this is how you add or subtract complex numbers. So let's talk about the multiplication of complex numbers. Multiplication of complex numbers. So in this, consider I just like x, like a variable, just like x, and replace I squared with -1. So you can see we just consider like x, and then whenever you see I squared, you can replace that by -1. So that's the only difference. So let's look at some examples. So let's say we have 2 plus 3i times, we just put a bracket for that, 4 minus I. So this means you can multiply. So when you write brackets like this means multiplication. So multiply. So what we can do, we can use the FOIL argument for that. So what we can do is, so you can use the FOIL or just like a simple multiplication. So you're going to first multiply 2 with 4. So you're going to get 8. And then you're going to multiply 2 with I. So when you do that, you're going to get negative 2i. And then do the same thing with the other number. So we have 3. So then 3 times 4. And then 3 times I. So what do you get when you do 3 times 4? You're going to get 12i. And then when you do 3i with negative I, you're going to get negative 3i squared. That's what you get. Now what we do, we can replace this I squared with -1. That's how we define I squared. Whenever you see I squared, you can replace that by -1. That's the definition. So now you can see this is a simple argument now. So we have 8 here, and then we have -2i and then 12i. This means that 10i, and then -3 with -1, you're going to get 3. With multiplication. So you have negative 3 with -1, so you get 3. Now what we can do is you can simply add these two numbers. So you get two real numbers. So you can see that you're going to get 8 plus 3, which is 11, plus 10i. So that's what you get when you multiply the two complex numbers. So let's do another one. Let's do this interesting multiplication. Let's say we have 2 plus 3i times 2 minus 3i. So this is a special type of multiplication. So the first one looks like a plus b, second one looks like a minus b. And we know that, when you have terms like that in complex numbers, we call the second one, or the first one, let's say the second one, we call the conjugate of the first one. So this is the conjugate of the first one. So it's conjugate of 2 plus 3i, or 2 plus 3i, you can say the conjugate of 2 minus 3i. So it's the other one. So when you multiply two numbers like that, so what happens is always you see the opposite sign. So that's what you notice, is it has the opposite sign. So if you go to the plus sign, you can write the minus sign. If it's a minus sign, you can write the plus sign, the opposite sign. So when you have the opposite sign, you call that is the conjugate. So when you multiply conjugate, what happens? We use the special product. When we have a plus b times a minus b, we know that you're going to get a squared minus b squared. This is an identity from algebra. This is what we call the difference of squares. That always happens when you multiply two conjugate. It's a difference of squares. That always happens. So that means you can square the first one, that is 2 squared, minus the second one is 3i. So the second one is 3i squared. So when you do that, what happened now? So you can see you're going to get 2 squared means 4, minus 3i squared means 9i squared. Because you have 3i times 3i, 9i squared. Now, as before, we can replace this I squared by -1. So when you do that, you're going to get 4 minus 9 times -1. So you can see you're going to get 4 plus, now it becomes minus become plus 9. So 4 plus 9 means 13. So you get a real number. This always happen. So you get a real number. This is 13. But there's also another way to get 13. So 13 is simply, you can see that if you look at the first complex number, 13 is simply 2 squared plus 3 squared. That's how you get 13. It's equal to 13. That's always the case. You simply square the two numbers and add them. That's how you get the number 13. That's always true. That's, you can remember that as a shortcut. So let's look at another example. How about we have 4i cube? 4i cube. What is 4i cube means? 4i cube means you're going to multiply 4i 3 times. So 4i and then 4i and then 4i. So how to simplify? You can see when you simplify, you first multiply the numbers. So when you multiply numbers, you're going to get, first you get 16, and even by 4 again, you get 64. So as numbers, you get 64. And then we multiply i's. So it's I times I means I squared. When you multiply by I again, so I cube. So you get I cube. Now what we're going to do, we're going to separate I squared terms. You can write this one as I and I squared. And then we know that the I squared is negative 1. Since I squared is negative 1, you can write this one as negative 64i. So that is how you can simplify a larger powers of I. So if you have anything more than I, you can always simplify that to get something just in terms of I. Because every time you have a like I squared, you can write as negative 1. If I to the fourth power, you can write as I squared times I squared. So it is negative 1 times negative 1, so you get is 1. So that always happen. So we can write these special cases for I. So we have I, and then when you square, you can write this one as negative 1. And then I cube, you can write as I times I squared. So that means negative I. And then I to the fourth power, you can write as I squared times I squared, which is negative 1 times negative 1. So you get 1. So you get 1. So that means if you have I to the fifth power, now you can write this one as I to the fourth power times I, but we know that I to the fourth power is 1. So that means you simply end up getting I. And after that, it's going to go in, it's going to repeat, because I4 is exactly like I. So that means if you have I to the sixth power, it's like negative 1. So like that. So if you look at I to the sixth power, so that's going to be negative 1. So that means they are going in a cycle. So if you start with I, so it's going to be, when you multiply, you get I squared. And then you're going to get I cube. And then you're going to get I to the fourth power. And then you're going to come back to I. So that's how the number's going to happen. Because we know that the I squared is, this equals to a negative 1. This equals to negative I. And then this equals to 1. And then you're going to get y. So these things are useful when you simplify with powers of I. Okay, let's see how we can divide now. So the division. So in complex numbers, the division is done as a multiplication. So division of complex numbers, division of complex numbers is done by a multiplication. Done by a multiplication. So for example, if we have a plus bi over c plus di, what we do, remember in the previous problem, when you multiply by conjugate, you get a real number. That's exactly the same argument we're going to use. So what we're going to do, we're going to multiply by the conjugate of the denominator, because when you do that, you get a real number. So that means what we do here, we have a plus bi over c plus di. What we do, we're going to multiply the conjugate of the bottom. That means we're going to multiply the top and bottom by c minus di, c minus di, because that's the conjugate of the denominator. That's the conjugate. So that's exactly what we do in this case. Just multiply by the conjugate of the denominator. So now what happened when you do that, and you can see the top is just a multiplication of two complex numbers. So it is a plus bi times c minus di, that we know how to do. And then the bottom is simply what happened is c squared plus d squared. That's a shortcut. It's always the case. It's going to be c squared plus d squared. And then you can see that this is just a real number. This is just a real number. So what we do, we just multiply the top and then multiply by the denominator, the real number we get. So that's how you do a problem like this. So let's look at a real problem and see how it's gonna work. So this is also the conjugate of c plus d. This d can be negative, so it's, even though we write it plus, it can be even minus. Okay, and then so in this you can just simplify this part. First distribute the top and then divide by the bottom one. So let's look at this through a problem. So let's do this one. Let's say we have this problem, 3 plus 4i divided by 1 minus 2i. So as we discussed, what we're going to do, we're going to multiply by the conjugate of the denominator. So that means we can have 3 plus 4i divided by 1 minus 2i. So we can multiply by the conjugate of the denominator. That means 1 plus 2i. That's the conjugate of the bottom. And then we multiply the top and bottom. Because this is like we multiply by 1. Now we can simplify this one. So and then we know that, so for the top, so what we can do is we can first multiply 3 with the two numbers on the other side, and then 4 with the 4i with the two numbers. So if you multiply by 3, you're going to get 3, and then if you have 3 times 2i, you're going to get 6i, and then we multiply 4i. So if you multiply 4i with 1, you get 4i, and then when you multiply 4i with 2i, you get 8i squared for the bottom, and we know that this is always 1 squared plus 2 squared. That's what you get for the bottom, a shortcut. And then you can see if you simplify, you can see that so we have I squared, which is negative 1, is equal to negative 1. So that means you can rewrite this one as 3, and then 4, we have 6i and 4i, which is 10i, and then because of the I squared is negative 1, you get negative 8 over the bottom is 5. And then you can simplify this again, so you're going to get 3 and negative 8, which is negative 5. So you get negative 5 plus 10i divided by 5, and if you divide by 5 both the top and bottom, actually if you can divide, we have denominator 5, so if you divide by 5 the two factors, two terms, you're going to get negative 1 plus 2i. We have to divide both. You divide both, so divide the first one and the second one by 5, so you get negative 1 plus 2i. So it simplifies very well. So that's what you get as the answer for this problem. So let's look at another one. So let's say we have 4 over 2 plus 3i. So we're going to do the same way as we did before. We're going to multiply the conjugate of the bottom. So that means 2 minus 3i and then 2 minus 3i. So for the top, you can see it is 4 times 2, 8 minus 12i. The bottom is 2 squared plus 3 squared. So that means it is 8 minus 12i over 2 squared means 4, 3 squared means 9. So you can see that, so this is 4 plus 9, which is 13. Now what we normally do, we can divide the both terms by 13. So that means we can write this one as 8 over 13 minus 12 over 13 I. So that's how we normally write the answer in a situation like that. Okay, that's about how you divide complex numbers. And I'm going to also talk about one more topic and how to find roots, because this is also very important in certain problems. So let's talk about that also. So for finding square root of a negative number, finding square root of a negative number. So let's look at the basics. For example, when you have x squared, which is equal to a constant d with, let's say, d is greater than or equal to 0, and we know that when you take the square root, you're going to get this many answers. So that means you're going to get two answers. So what are those two answers? You can see that x equal plus or minus the square root of d. If d equals 0, you only get 1. So that's what happened in if we in the real case. So you're going to get plus or minus square root d. But the question is, if you have a negative number, like if x squared equal to negative d, if x squared equals to negative d, and we assume that again d is positive. So the question is how we can do a problem like that. So what we can do, we can use a simple trick, because we know that the I squared is negative 1. So we can replace this negative sign with the I squared. So we can write this one as x squared equal d times I squared. So that's what we do. We replace the negative sign with I squared, since I squared equal negative 1. Now we can take the square root of both sides. When you say the square root, again you get two answers. So x equal, again plus or minus, take the square root of the number and write I after that. So I is not with the square root, it's outside. So that is how you're going to solve a negative, like when you have x squared equal a negative number, this is how you're going to solve. You take plus or minus, there are two answers with square root of d and I, and it will be very clear like why you get two answers. For example, if you look at x squared equal 4, and you can see that there are two answers for this problem. It's not just 2, it is plus or minus 2, and you can see both of them works. So that happens every time, because plus or minus. Okay, so let's look at some problems now. Let's do find the square root first. So let's look at three examples. So let's see square root of 16. So square root of 16 is, you can see when you take the square root, you get 4. So that is easy. So how about this one? Let's say square root of negative 25. So then we're going to use the square, when you enter the square root sign, that means the principal one, the positive one. So we're going to do the same trick as before. We're going to write this one as 25i squared. You replace negative with the I squared, and we take the square root. Once you take the square root, we only get the positive one. When you write the square root sign, that means the positive one. So it is square root of 25, square root of 25 times I. So that means the answer is 5i. I'll get one answer here. And then third one, so let's look at a situation like this. What about negative 12 square root? Because negative 12 is not a complete square. So what do you do in this case? We first gonna write this one as, we know that 12 is 4 times 3. So we can write this one as square root of 4 times 3. This is just exaggeration. And then negative we write as I squared. And then we take the square root of every term. So square root of 4, which is 2, square root of 3, which is 3, I squared, we write 1 as I. So those are the answers for those three problems. And then let's look at a solved equation problem. Solve the equation. So let's look at the first one. X squared equal 4. So if your x squared equal 4, according to the formula, this is simply going to be x equal plus or minus. You take the square root of the number. So that means this is going to be plus or minus 2. So that is the easy one. So let's see now with the complex number. So let's say x squared equal negative 25. So it's the exact same numbers from the previous problem. So this equals x plus or minus, we take the square root of the number and then put a I. So that means this is plus or minus 5i. And then also we can look at this one, which is x squared equal negative 12. So as before, we can write this one as x equal plus or minus, so take the square root of the number I, and but we know how to take the square root of 12, which is because 12 equal as before 4 times 3, so take the square root of each term. So it's going to be plus or minus 2 square root 3i. So that is how you solve these problems. So these are the basics of complex numbers. So you can try these problems as practice problems now. These are the practice problems, and you can find the answers in the description.